So to count the number of handshakes that we have, we're going to add up, like they said, the number of handshakes. Since there's 28 people, the first person will shake hands 27 times. Okay? The next person 26 times, etc., and we're getting to that total. Okay? Then the problem changed to 50 people, okay? Which would make this expression right here a little more complicated and would get kind of annoying if you had to keep putting that into your calculator. Agreed? Like, what if I changed the problem to 1,000 people? Do you want to do like 999 plus 998? You'd be like, this is so stupid and a waste of my time, right? So there is a quicker way to calculate it, and what you see right here is the quicker way to calculate it, but the question is, where did that come from? So that is what we're going to look at. So keep in mind the problem was about 28 people, so we said 27. Yeah, thought I solved all my problems. 26, 25, all the way down to 1. I'm going to do it like 3, 2, 1. So instead of putting this into the calculator, you can notice there is some pattern of what's going on here. 27 and 1 add up to what? 28. 26 and 2 add up to 25 and 3 add up to. Is this pattern going to continue? Yes. Okay, it's only going to continue because our numbers, okay, in this list, in this sum, have a specific pattern that they're going down 1 every time. So that's why every time we move down 1 here, but come in from the other side, it's going up 1, and it's creating that same sum. Okay? So we come up with this sum of 28. Okay? But how many times has that occurred? So how many terms were there in this list, this series? 27. There were 27 terms in this series. Okay? But did we use 28 really 27 times? No. Each number was paired up with another number, right? Which means we would use it half as many times. So we have the 28 times the 27, but we're going to cut it in half because we're not really using that sum of 28 27 times. We're using it half as many times because all of our terms are being paired up with another term. Okay? Does that make sense? All right, so let's look if it wasn't up by 1 and down by 1, but it was still arithmetic. So somebody tell me what it means to be arithmetic, because we talked about this last time. Yeah. Good. We add or subtract the same number or the same amount each time. So let's say I come up with a different arithmetic sequence, but these have plus signs between them, and we'll talk about what that's called in a minute. Let's say my starting term is 5. What do you guys want my common difference to be? You could even do a negative one if you wanted, like we could subtract if you want. 2. Okay? So if we go up 2, it'd be like 5, 7, 9, 11, right? And this is going to continue. Okay? Let's say that I wanted to add up. I'll make it small so that we don't have to write it out forever. But let's say that I wanted to add up 10 terms of this sequence. So 5, 7, 9, 11, 13, 15. Tell me when to stop when I'm at 10 terms. Okay. Am I there yet? Yeah? 5, 6, 7, 8, 9, 10. All right. So let's say I decided I want to add all these up. Okay? To make it look similar to the problem that we were just solving. Okay? So let's look at what happens here. When I add 5, I don't know why it's doing that, sorry. When I add 5 with 23, what am I going to get? 28. And when I add 7 with 21, what am I going to get? 28. I didn't mean to pick something that had the same sum as the last time. But so these things are adding up to 28, right? I had 10 terms in my list, but am I really using 28 10 times? No, because the 28 is formed by this term being paired up with another term. So I'm really only using 28 half as many times as I would have before. So do you guys see that no matter what your common difference is, you're going to be able to use this idea or this pattern? Yes? yeah, you can, yes, it would be 27 times 14. Yes, you're right. That's fine. Okay. All right, so do we get this idea? Okay, so let's try to write this in a formula or some sense of what's going on. Well, multiplication and division, you only will divide one of these by 2. Which one? Whatever is going to be most convenient for you, but only one of them would be divided by 2. Now, if it was 28 plus 10 over 2, then there would be a different idea happening there. Okay? So, where was the 28 coming from? Okay. Well, that's where it was coming from in the last problem. Where is 28 coming from in this sequence? So the sum of the terms, right? Which happens to be the sum of a bunch of pair of terms. But would you guys agree that it also happens to be the sum of the first term, right? And which one? The first term is always paired up with the last term when we were looking at this pattern. In this case, it was the 10th term. But if we don't know, we'll just call it the nth term. Is that okay? So this idea right here, the 28, is coming from the sum of all these things. Okay, the first term and the last term in the list. Where was the 10 coming from? Good. The number of terms that I was actually looking for, which, remember how I just said that could have been 10 because we were using 10 terms? Okay. This is the number of terms which should match your n value. So if I was not going to say like the number of terms in words, I would use n to represent that. And then what did I have to do each time that I did those operations? Divide by 2, because we weren't really using it that many times. We were using it half that many times. Okay? So this formula that we just came up with is actually the sum formula for our arithmetic series. So did you guys get the rest of the note guide? The second page of it that was posted online? If not, you just write it down. It's fine. Okay? All right, so notice that this is titled arithmetic series and not arithmetic sequence. Okay? Series is a sum of the terms of the sequence. So instead of just being a list with commas between the values and each value representing something separate, you use the word series when you have the same pattern going on, but instead of just wanting a list, you want to actually add everything up in the list. Okay? So the word series is described just like a sequence, but you want to add everything up. Okay? Can you guys see it okay or no? An arithmetic series is the series whose terms are just like the arithmetic sequence. So they had to have that common difference. So you guys saw that the difference was -1 when we were looking at the handshake problem, right? And then I just made up a series up here, and it was thrown out that we wanted to try +2 as the difference, and so I used +2 as the difference in that series. Okay? So series, like a sequence, but we're adding up the terms. Arithmetic still has the same meaning. Finite series means it ends. So you can call something the first term, and you can call something the last term. Okay? And infinite means it continues without end. We're not going to do much with infinite series here, but it's important you know what they are. They'll come up later on. Okay? Any questions about any of the terminology? I know you guys are taking time to write them down, which is fine, but yes. It can be finite or infinite. So finite and infinite are words that are like different adjectives to describe the series than arithmetic. So arithmetic tells me what kind of operation is happening between terms. And then finite or infinite will tell me whether or not it ends. Okay? So you could say it's a finite arithmetic series or an infinite arithmetic series. Yes? Yes. All right, so again, mathematicians are lazy. So instead of saying, I want you to add all these things up, or always having to write out the whole list with the plus signs in between them, they don't do that, okay? Instead, and you can look a little further in your note guide and see it down at example 3, they use some different notation called sigma notation. So it's called sigma notation because it uses the Greek letter sigma. sigma means I want you to add up a bunch of terms. Okay? Then what they'll have is they'll have instructions basically structured around the sigma symbol. So for example, they might have something like n equals 2 or k equals 1, something with a variable and what it's equal to at the bottom, and then a number at the top. Okay. This is telling you which term to start with, and this is telling you which term to end with. So if this was written out as a list, you would basically be adding together the second term all the way up to the fifth term. So you would be adding the second, the third, the fourth, and the fifth term together, and that would be it. Does that make sense? Mm-hmm. How do you know what the terms are? So after the sigma, they put a rule, an explicit rule, like the rules that you were coming up with in last night's homework or the homework over the weekend, that tells you how to figure out which terms you are adding up. So let's say here the rule was 2n plus 1. What this means is if I want to see, so this would be a whole problem right here. Okay? And I would read this problem even without any instructions. I would go, oh, I know what they want me to do. There's basically a list. The terms in the list can be determined by this rule. And what they want me to do is add up some specific terms in the list. The second one all the way to the fifth one. So do I care what the first term is or the sixth term or something like that? Not necessarily in this case. So if I just wanted to look at which ones I'm adding up, so this would be the problem right here. I'm going to show you guys what that looks like right here, like if I were going to complete the problem. Okay? So the first term I want to add up is what I'm going to get by using this rule and plugging in 2. Okay? So I want to think about what would be 2 times 2 plus 1. Okay? So that would give me 5. 5 would be the first term that I'm using in my addition. It has nothing to do with the fact that this is 5. Okay, that's a whole different ballgame. The next term that I want to add up in this series is going to be the term that comes after the second term. So they said to start at the second term. You don't just jump from the second to the fifth. You always go in consecutive order until you get to that last term. So if you started at the second one, the next one is going to have to be the third. Okay? So then what I'm going to do is look at what's 2 times 3 plus 1, because that's what the rule says to do, which would give me 7. Yes?
So the numbers on the top and bottom of the sigma, they're just like
Ends. Term number. Yes.
So not the actual number that's
No.
in the spot, they're just like...
That's why it's kind of cool if they use the n as the variable, because that helps solidify that idea that it's not the a value, it's not the number in the list, it's just the spot that it's occurring in the list. Okay? So I plugged in 3. I'm going to then go ahead and plug in 4. So that would give me 9. And you might see a pattern start forming where you feel like you don't have to plug in anymore. You could get the rest. That's fine. And then I'm going to plug in 5, which is going to give me 11. Am I going to plug in 6? No, because the directions, according to my sigma notation, were just to add up the terms from the second term to the fifth term. So this is like the second, third, fourth, and fifth term in this specific sequence, or a series in this case, because we're adding. And then we would just go ahead and add all of that up. So our final answer would actually be a total. Okay, so the answer to this is just a simple numerical value, because what you've done is used the rule and the starting and ending points to add a bunch of things up and get that total. Okay? So sigma is just a notation we use to get directions without having to write them all out about where to start and stop and what the rule is of the series we're adding together. Does the notation make sense to you guys? All right. Now, before we start example 1, next to it, I want you guys to write the sum formula that you came up with. So sigma is not a formula. Sigma is just a way to write things differently. Okay, it would be like me writing out, please use the rule 2n plus 1 and add up the second term till the fifth term of the series. But I don't want to write all that out, so I just use sigma. The formula for adding things up, kind of like the rule that we came up for arithmetic series. So a little reminder, that when we were studying the arithmetic sequences last time, we came up with a way to write the explicit rule if it followed the arithmetic pattern. Kind of helped make the last homework easier than the first homework, right? Because there was the same pattern that everything was following. Does anybody remember what the rule was? Yes? Good. So if we knew the common difference in the first term, we could then plug in any n value to figure out what the term was in the sequence. Okay? Now, when it turns into a series, when they want you to add it up, there's a formula for how to add up the terms of the series. And we actually already figured the formula out in our math moment. Okay? The notation is going to be an S for sum. It's still going to have the subscript of n next to it because it's telling you sum up this many terms, the first 10 terms, the first 15 terms. Unlike sigma, if this said S sub 5, I would think it meant the first 5 terms, from 1 all the way to 5. This is kind of just giving me the stopping point. Okay? I would assume I'm starting with the first term. Sigma, you only start with the first term if 1 is the number at the bottom of the sigma sign. If they change it, then you have to change it accordingly. Okay? So to get the sum of an arithmetic series, so we already did it. What did we say you had to do? We did it in our math moment. What were we doing when we were adding up those lists of numbers that had that specific pattern? Okay, we combined two terms. Specifically, we could say it was the first term and the last term. So in this case, notice I'm just going to use that n subscript. So if they want me to do 10 terms, this is going to be the 10th term. But if they only want me to add up 5 terms, then this is going to be the 5th term, right? I'm going to do that. Then what did we multiply it by? The number of terms, which again is going to depend on how many they want me to add up. So I'll just call it n. And then what did we have to do with it? Divide it by 2. You might not see it written exactly like this. You might see sometimes they write it like n over 2 times a1 plus an. But you guys have to, and if you're struggling with manipulation of equations, then come see me because you have to be okay with the fact that these are the same things using the properties of numbers that we know. Okay? So we figured this out in our math moment, but this formula is going to help us answer questions about the sums of different series. Okay? So in example 1, you see that there's an arithmetic series. Okay? Tell me some things you know about that series up there. Some important pieces of information that you can identify by looking at the series. Yes? Okay, so it's going up for 5, and we named that 5 as what part of our series? Yes? The common difference. So our common difference is 5. What else is important for us to note from what's up there? What else might be a key piece of information that we may have to use in our rule or to find our sum? Good. The first term is 3. So it's kind of nice when they give you the actual series because you can see the first term and you can identify the difference pretty easily. Okay? So the first thing it asks us is to find the sum of the first 40 terms. Okay? So we're looking for the sum of 40 terms. Okay? Now, we could list them all out and try adding them up in our calculator, but we already found a shortcut. And we know the shortcut is add together the first term and the 40th term, multiply it by 40, and divide it by 2, just like we did with the math moment problem and with the sequence that we put up after that. Is that okay with everybody? Okay. So the first term is not hard to identify. What's our first term? We already identified it, 3. I want to add that with my 40th term. Okay. I want to multiply that by 40 and then divide by 2. So the only thing that's really hard for me to figure out here is what is the 40th term. Okay. Now I could just keep making the list to 40. Can anybody think of another way I could figure out the 40th term? Because maybe 40 is not such a big deal, but if it was like the 400th term, would you want to keep writing the list till you got to the 400th term? No. Good. We can use the rule. Okay. So we want to go to our rule and we want to find just the 40th term. Okay, so it's kind of like a little side trip that you have to take mathematically. So we're going to go over here and we're going to find what is that 40th term that we're looking for in order to complete this calculation. So when I look at my rule, I need the first term, which I have, which is 3, plus n minus 1. What's n in this case? 40. I'm looking for the 40th term specifically. So I'm looking for the term that's in spot number 40. So 40 minus 1 times the common difference. What's our common difference? 5. We already identified it. Okay. Yeah, you guys get out those calculators. You can tell me what this is. Is it 198? Having a good arithmetic day today, right? All right, so 198 is going to come and fill in this spot right here for my sum formula. But notice I had to take a little side trip to figure that out, and that's okay. Now if I complete this calculation, I'm going to have what the sum is for this series. Okay? So 3 plus 98 is going to give me 201. I'm going to multiply that times 40, and I'm going to divide by 2, which is going to give me 4,020, correct? Okay. So the sum of the first 40 terms is going to be 4,020. Yes. Yeah, that's fine. Yeah. Okay, she's saying right here, could I divide 40 by 2? Because of how multiplication and division work, that would be fine, and then just do 20 times 201. That's fine. Any questions about finding the sum for that problem? All right, so then let's think about part B. We want to find n such that s sub n equals 570. So take a second in your groups and talk about how are you going to find n such that s sub n equals 570. Like, what would be your approach? Talk with people in your group. What do you know? What can you figure out? Okay, so let's start with taking, since we have the sum, and try and thinking of it in this formulaic sense, where we have the first term, the last term, times n over 2. And the idea was first, maybe just multiply it by 2 so we don't have to deal with that number being there. So we get 1,140 equals, and we have a1 plus an times n. All right, any ideas what to do here? Yes. Good, we can definitely plug in the first term. So I'm just going to go ahead and erase a1 and plug in my first term. Okay, so my first term, as I can see from the series, is 3. Okay. All right, now I have a problem if this is all I know, because there are 2 variables in this problem right now, n and a sub n. Okay. I can solve it if there's only 1 variable, but with 2, I would need another equation with 2 variables and be able to use that somehow. So do you guys have a way, possibly, that I could rewrite this equation using only 1 variable instead of 2? And keep in mind, what are we trying to solve for? N. So I'd really like the variable to be n. Yes? Good. Good. We could use the rule again. It can substitute for an. So if I substitute the rule for an and I know a1 and d, the only variable that's going to be left in here is going to be n. It's a bummer to have the variable, but it matches the other variable, and so that could be really nice. So for this substitution, think about what the rule looks like with the first term and the common difference plugged in. And if you want to, you can even simplify it if you want to use it in a simpler way. So it ends up looking like 5n minus 2. So I can use 5n minus 2 in my problem instead of an. All right, what next? Yes. Distribute n. So I'm going to have 1,140 equals. Are you guys okay if I do the 3 minus 2 before I distribute the n? Yeah? So I'm just going to call that like 1. Sorry, that looks a little bit ugly. But I'm going to get 5n squared plus n. What kind of equation is this? Anybody remember what we call this kind of equation? Yes. A quadratic. How can we solve quadratics? Yes. Good. I want to set it equal to 0. So I have some work ahead of me here. So 5n squared plus n minus 1,140 equals 0. Now, how am I going to solve this? What are my options to solve a quadratic? Okay, I could look for completing the square and making it a perfect square. Okay, the 5 might make that a little bit difficult. What else? Quadratic formula. What else? Okay, good. Yeah, what are we doing if we're using that x thing? Factoring, because we're really trying to set up something like this. Okay, so you guys help me with some manpower here. We have to figure out there's a way to break 1,140 into 2 terms so that the middle term is only equal to 1. Okay? So go ahead and figure that out. All right. So once you have this, though, so you have 5n minus 76 as a factor, and n plus 15. Yeah, the 76 should be positive. Like that? That's what you mean? Yeah, that's right. So it should be minus 15 and plus 76. Now, how do you solve this once you've factored it? So I'm not so concerned about the factoring part. Okay. So if we set each of these equal to 0, we get that n is equal to 15 and n is equal to negative 76 over 5. One of these is okay. One of them is not. Yes? Okay, I agree with you. So 15 is a correct answer, and negative 76 over 5 is not. Why not? Yes? Good. It's a term number. It can't be negative, and can it be fraction? No. So that's multiple reasons that wrong, but it can be 15 terms that we're adding together. Okay? The factoring part won't be as hard on any of the problems that you have, or it shouldn't be. If it is, then I give you permission to find something that will solve the factors for you. All right. Okay. All right. So find the first 3 terms of an arithmetic series in which a1 is equal to 5 and an is equal to 100. You guys will be able to do this. We're going to skip to example 3. Sorry. It's more important. All right. We're actually going to do part B first, because if we only have a little bit of time, I want to make sure we get that done. All right. So sigma notation. What if you don't want to write out all the terms? Like, what if the numbers get big? How can we do this? You're still finding a sum, so you can still use this formula. You just need to get all of that information from the sigma notation. Okay? So how are we going to get the first term? Now, I'm using that loosely. This says the first term. What do we really want to be the first term in our addition problem according to this sigma? Fourth. So I'm going to figure out what the first thing is I'm adding up by actually plugging 4 into the problem. Okay? So what do we get? 4. How are you going to find the last term that you want to include in the addition? Plug in 12. And when you plug in 12, you get negative 4. Okay? All right. For the n, we have to decide how many terms that we're adding up. Now, keep in mind you're adding from the 4th term to the 12th term. So just on a side note, think about in homework, I'll put it over here. Think about in homework if you're assigned problems 1 through 50. That would be 50 homework problems that you are assigned. But if you do 50 minus 1, that actually gives you 49. When we're using subtraction, it supposes that 50 was already counted previously. It doesn't count that as part of the numbers included in your 49 problems. So if we want to figure out how many problems there are, we would do 50 minus 1, we'd get 49, and then we'd have to add 1 because it didn't count the beginning number that we started with. So using that logic over here, since n starts at 4 and ends at 12, I would do 12 minus 4, which is 8. But I would have to add 1 more to it to count for the starting point, which means there's actually 9 terms being added together. Then as we finish this, this is 0 times 9 over 2, which is 0. So the sum in this case is 0. All right, your homework tonight is homework 3, so I hope that helps.